Hello everyone, this is grade 6, module 1, lesson 29, problem set. What we're going to be doing again for this lesson is percent problems including part, whole, and percent. So we're going to be using this to find our missing values. I'll be doing some of these with diagrams and models, also some of these using straight calculation for it. Which we did in the lesson earlier today. So the very first thing that I want to do is take a look at one. And it says the Sparkling House Cleaning Company has cleaned 28 houses this week. If this number represents 20%, or 40%, sorry, of the total number of houses the company is contracted to clean, how many total houses will the company clean by the end of the week? I'm going to do two different ways to solve this one, because I think this one is nice enough to lend to a double number line and also to calculating out. So I draw my number line and I'm going to have the percent on the bottom and I'm going to do my number on the top. So I'm starting at 0 and my first one that I'm given is 40%. That represents 28 houses. So that's going to be the number of houses on top. Now, I can't go 40 to 100. I know it can get to 80 and then I'm up over 100 if I count by 40s. But I know if I can count it I can cut it in half. And these are just equivalent ratios or equivalent fractions. So if I go down by 20, what I just did was divide this by 2. And I know if I do a division of 2 here, I have to do a division of 2 here because I want to keep them equal. And I'm not really dividing by 2, I'm dividing by a 2 over 2, which is a 1 whole. So if I divide 28 by 2, I get 14. So every 20% I go up, I have to go up 14 hives. Or not 14 hives, 14 houses. Sorry, getting ahead of myself. So if I go up another 20%, that'll give me 60. I got to go up another 14, which is 42. If I go up another 20%, I'm going to go up another 14 up here, which is 56. And then I got to go up my last 20%, which will be my last 14, and that's going to be 70. And what that represents is how many total houses will the company clean? 70 houses. Now I'm going to do a quick show, or a quick way to show you how to do this without using a model. I know that I have 40% was my start. I'm going to change that into a fraction out of 100 because percents are out of 100. And I'm going to simplify this down. And I know I can divide by a 20 over 20 because it goes into both. So I have 2/5. Well, I know that the 40% represents the part, and that's 28 houses. So I'm looking for the whole amount here. And again, we have to know part compared to whole. So in order to get 2 to 28, I have to multiply that by 14. And again, if I multiply 1 by 14, I have to do it by the other because it's not 14, it's 14/14. 5 times 14 will get me 70, and that's my whole amount. So that's a way to do it with calculation rather than with a model. Let's take a look at 2. And I'm going to slide down a little bit. Okay. 2 says, Joshua delivered 30 hives to the local fruit farm. If the farmer has paid to use 5% of the total number of Joshua's hives, how many hives does Joshua have in all? So this is telling me 5%, which is 5 out of 100, equals the number of hives that the fruit farm or the farmer is paid for. So that's the part. That's 5%. 30 represents 5% because we want to know how many in all. So we want to know the whole amount here. Now this one really lends itself to just calculating out, because all I have to do is take the percent and figure out how to get to the part. And I know 5 times 6 will get me 30, meaning I have to multiply the bottom by 6, because we're not multiplying by 6, we're multiplying by 6/6. Has to be the same number on top as on bottom, so we can make sure that that's a 1 whole that we're multiplying by. So 100 times 6 is 600. So Joshua has 600 hives in all. And that's one way to show that representation. Now, we could count by 30s to get us up there, but we'd have to do 20 different 30s to go up to it. So I feel like this one kind of lends more to not using a model for the sake of this. But I could use a hundreds chart. That would be easy to figure out how many of these I would have to shade in. But for the sake of time, there's our calculation for it, because it doesn't say we have to use models for it. So for this one, I'm staying with just calculating with numbers instead of using a number line or anything like that. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.